So let us start with celestial navigation basics. So this is Earth, and we will see this is the celestial sphere. So celestial sphere is nothing but an imaginary sphere, which is so concentric sphere means that Earth and its celestial sphere both are having the same center. It is a concentric sphere. It is an astronomical projection of Earth on the infinite distance, infinite radius. So this is why it is called a celestial sphere. All the astronomical bodies like your stars, moon. So you can see this class is closer and this class is star is far away. But for for astronomical navigation, the stars are very far away. But that's why they are projected all on celestial sphere. So for studying celestial navigation, we have to assume that all heavenly bodies, stars, moon, sun, planet are all on the celestial sphere, which is a imaginary constant uh, sphere concentric to the earth at an infinite radius. So all planets are projected on the celestial sphere or assumed to be on the celestial sphere. So this is all about celestial sphere. Now let's see, this is the earth and the celestial sphere, and you have the poles. So earth has geographic north pole and south pole, and the projection of north pole on the celestial sphere is the celestial north pole, and the projection of the celestial south pole on this is called the celestial south pole. So let's continue with so your uh, then we have latitudes which are there. So this is equator and this is latitudes on the earth, we know. And after expanding the equator up to the celestial sphere, the great circle which is passing as a parallel of equator of the earth is called equinoctial, which is equinoctial is the expanded equator of the earth on the celestial sphere. So this is the equinoctial. So equinoctial is basically the equator of the celestial sphere. So definition of equinoctial is it is the great circle which is passing through the center of the earth and 90 degree from each celestial pole. So 90 degree away from north celestial pole and south celestial pole. So since we have expanded the equator lines, now we will expand the latitudes also. So the expanded uh, latitudes are called declination. So you can say latitudes of celestial spheres are called declination circles. These are small circles because they are not passing through the center of the earth and they are parallel to the latitudes of the earth. So this is all the lines of declinations of the celestial sphere and the equinoctial of the celestial sphere. So only equinoctial is a great circle and rest other are small circles because they are not passing through the center of the earth. So we know we are clear with equinoctial, declination circle, celestial sphere, north. So we'll see the poles again. So this is geographical North Pole, South Pole, and celestial North Pole and South Pole. And then we have the longitudes. So if these longitude lines are projected on the celestial sphere, these will be called meridians. Longitude are also called as meridians. So they are also called celestial meridians. So celestial meridians are the projection of Earth's longitudes. So this is the whole picture. Poles of Earth and celestial sphere, longitudes and meridians, declination, equinoctial. Now let's see how to define declination. So declination is this small circle, and if you have a celestial body, so we are defining the declination of a celestial body with sun. So as we know, we will assume the celestial body is on the celestial sphere. So we have assumed the sun to be on the celestial sphere. So declination is the arc on the celestial sphere. So this is the complete celestial sphere, and declination is the arc of the celestial sphere. So since all these lines are celestial meridian, this outer line is also a celestial meridian. So declination is the arc of the celestial meridian, or the angle subtended at the center of the earth, arc or the angle subtended at the center of the earth between the equinoctial and the declination circle. So it's very simple, and the declination circle passing through that body. So if you want to define declination, declination is the arc of the celestial meridian through which the body is passing, or the angle subtended at the center of the earth between the equinoctial and the declination circle of that body. And it will be measured same like latitudes north and south of the equinoctial. Going up to maximum 90 degrees. So we have covered till declination, meridians, and north poles and equinoctial. Now let's see GHA. This is also called Greenwich R angle. So all the GHA, LHA, all are angles at the celestial poles. Remember always. So since the word suggests Greenwich, so let us take a celestial meridian which is passing through the Greenwich, this red one. So this red line is the celestial meridian which is passing through the Greenwich. Now let's bring the equinoctial. So this is the equinoctial of the celestial sphere. Now we know that this equinoctial is a great circle which is passing through the center of the earth. So if I take a part of this equinoctial, we can call it as the arc. So part of the equinoctial will the arc of the equinoctial. So now let's bring a celestial body on one celestial meridian. So this is sun on one of the celestial. So now we will define the GHA of the sun. So this celestial meridian is cutting the equinoctial at 90 degree. So to define GHA, Greenwich R angle of a celestial body is the arc at the equinoctial, or the angle at the celestial pole contained between the Greenwich celestial meridian or and the celestial meridian passing through that body, measured westwards. So Greenwich hour angle or GHA is the arc at the equinoctial, very simple, and or the angle at the poles contained between the Greenwich celestial meridian uh, and the cell celestial meridian passing through their body measured westwards. So it's very simple and no need to remember the definition. And you can make with the figure. Now let's see the local R angle. Local means there is an observer in this definition. So local R angle is with reference to an observer. So this is the observer on the earth on this celestial meridian. So this celestial meridian is the projection of the Earth's longitude of that observer. So on celestial sphere, this is the meridian of the celestial body, blue one. So let's say the starting of the definition is again same. It is also measured westwards. So it is the arc on the equinoctial or the angle measured at the celestial pole, measured or contained between the celestial meridian passing through the observer and the celestial meridian passing through the celestial body measured westwards. So very simple. From the yellow line to the blue line, this is LHA. And it's very easy to define with this figure. So LHA is clear. Now let's see SHA. So for that, we need to understand SHA. We need to understand what is first point of Aries and first point of Libra. So first, let's see what is first point of Aries. So this equinoctial is this is a 2D. We make this 3D diagram. So this is how the equinoctial will look like as a 3D in a great circle. And let's make the path of the sun, how the earth is moving. We know that the sun's path is maximum up to 23.5 degrees north, and then it will come down to 23.5 degrees south, and this is how the sun will travel. So now as you can see, this is the equinoctial red one, and yellow is the traveling path of the sun. So when this earth meets the earth's path meets the equinoctial, intersect each other, this point is called first point of Aries. So to define first point of Aries, it is the point on the surface of the celestial sphere where the sun's traveling path crosses the equinoctial from south to north. When the sun is moving from south to north, that is first point of Aries. And this is denoted by lambda, gamma. And at this point, the sun's declination is 0 degree because it's on the equinoctial. So this is about first. So this first point of Aries is on the Greenwich meridian, that is 000 degree, and so longitude is also 0 and latitude is also 0, that is celestial meridian and equinoctial both are 0 declination. So if we go opposite 180 degrees celestial meridian, then it will come opposite from the other side, and the sun is going from north to south, and this point will be called first point of Libra. It is denoted by gamma. So first point of Libra is the point on the celestial sphere where the sun's path crosses the equinoctial while going from north to south. Now let us understand what is SHA. So now you can understand easily. SHA is the sidereal hour angle, and you can see this is Earth and this is Sun and this is a star. So this location of stars are very far away from the Earth. So if in comparison to Earth we have an observer, so this star are very far away as compared to the Sun. So if there is a change in the position of the Sun, the GHA and declination of the Earth will change. That is the longitude and latitude of Earth the Sun will change when they are changing. But because stars are very far away, so the change in their position is not is less compared to the Sun. And if we keep on putting all the values of GHA and declination, that is latitude, longitude of star in the nautical almanac, it will become very bulky and costly. So to avoid the nautical almanac to be bulky and costly, that's why they introduced the SHA was introduced in the nautical almanac for stars. Now, what is exactly this SHA? SHA and declination of stars for they are tabulated every 3 days. Because the change is less in the star's position, that is why they have not put it every day, they put it every 3 days. So we have the SHA and declination for stars every 3 days in the nautical almanac, and we have taken only 1 point or 1 star, that GHA Aries, for each day and every hour of GMT. And by with the help of 1 star comparing, we will be able to derive the SHA of and GHA of all the other stars. So by using GHA of Aries for the time required and by applying the SHA and declination of the star, we can get the GHA and declination of the star. So you see this nautical almanac, GHA Aries is given for every day and every hour of GMT, but rest all stars you can see is only SHA and declination are given, and all these are stars, they are for only 3 days, they're 17th, 18th and 19th. So we will see later on in the nautical almanac. This is just to show you if it's not clear. So now we are clear that uh, let us define what is SHA. So definition, so SHA is again is the arc of the equinoctial or the angle subtended at the celestial pole contained between the first point of Aries, celestial meridian passing through first point of Aries, and the celestial body to the star. So previously it was Sun, and the difference, it is same like your GHA, but GHA was passing from Greenwich meridian, and SHA is passing through the celestial meridian of first point of Aries. Celestial meridian passing through the first point of Aries, and the celestial meridian passing through the celestial body, whatever you can say, measured westwards again. So this is very much clear to us. Now let us see how with the help of SHA we can get GHA of any star. So let us say from almanac we got GHA Aries as 10 degree west. So what is this 10 degree west? That is towards the left side. So from so Aries is not exactly at Greenwich. So GHA to Aries is 10 degrees west. Now from the almanac, I can find out that SHA of a particular star is 30 degrees west. So SHA of the particular star is 30 degrees west. That is from first point of Aries to that star is 30 degrees west. Now what do we need to find out? We need to find out the GHA of star. So GHA of star is the main goal, and that we can find out from Greenwich to this star. So we can clearly see that from Greenwich to the star, we add this shaded area and this shaded area. That is nothing but we have to add GHA Aries plus SHA star. That is 10 degrees west plus 30 degrees west is equals to 40 degrees west. So GHA star is equal to GHA Aries plus SHA star, which is very easy to remember. No need to remember the formula. So this is the SHA star.